Okay, we're going to look at, well, that's actually the best place for it. We're going to look at a difference of squares. And a difference of squares is a pretty unique, it's not even a trinomial, it's technically a binomial. It's a pretty unique situation that we can do a specialized type of factoring in. Essentially, I'll write the idea of it is we'll use the letter a squared, and they say the word difference, so it has to be subtraction. So you're looking for scenarios where you have two terms, so a binomial, and you can find the square root of the first term and the square root of the second term. If you can do that, you'll end up in a scenario where you'll end up with the square root of the first term being the first term in each bracket, the square root of the second term being the second term in each bracket, and then you're just going to put a plus and a minus sign in between the two. Okay, so this is like the fast way of factoring it, and then we'll kind of talk about other ways we can do this. Now, we're not dealing with typical difference of squares introduction here, where you'd have like I'll give you a really easy example of this. You might have something like 9x squared subtract, 25. Right away, I can see square roots of 25 are 5, square root of 9 is 3, and I can work with these values, technically the 3x, right? We're working with a more unique scenario here. And one of the ways you can simplify something like this is because we have sets of brackets, you can build some let statements into this, okay? So we could say let y equal t plus 2, okay? And what that does is it allows us to now take the original equation, 4t squared, subtract, and we're going to replace t plus 2 with y, and technically it's squared. Okay, now this looks a lot more like what we have here. If you notice, 4t could essentially be our a, y could essentially be our b. So I can really quickly find out what the square roots of these two things are. I'm going to jump to the side here and put them in green. I need to find the square root of 4t squared. Think of this like you're taking the square root of both of them. So t squared, the square root is just the value of t, and square root of 4 is 2. Technically, when we square root things, we have a positive and negative answer, but we're only working with the positive ones in this case. It's just the way the factoring works out. It doesn't mean when you square root, sometimes we only take the positive or negative. It's just we're using a shortcut to help us with looking at a style of factoring, okay? So we're kind of cheating when we're using our square root here. 4t squared is 2t, and the square root of y squared is just going to be y. So I can instantly jump to my second set of brackets, just the same way we'd set it up in our example here. I really did no extra written out work. I'm just jumping to the set of brackets, and my a value, which is the square root of the first term, happens to be 2t. That's going to be the value that goes into the first term in each bracket, so 2t and 2t. And our b value, which happens to be the y, is going to be the second term in each bracket, okay? And the final touch to this is you just put a plus in between one set of brackets and a subtraction between the other. It doesn't matter which one. But in this case, we're not technically done because remember we had that let statement? We need to substitute in t plus 2 for that y value again. So there's a little extra work, t plus, and now what I'm going to write it in red. Y is now going to be t plus 2. So all this means is we have to do a little extra simplification at the very end. It's not a huge deal. 2t subtract. We'll do that in red to show that we've substituted in for y. T plus 2. Okay. Think of this as like positive 1 being distributed, so we can drop the brackets. You end up with 2t plus t plus 2. Over here you have 2t minus t. And this is distributing a negative. So you distribute the negative to the t and to the 2, so minus 2. And then when we finally simplify, 2t plus t is 3t plus 2. And 2t minus t is actually just t. Think of it as a coefficient 1. 2 subtract 1 is 1, so we have the 1. We don't have to write it in front of the t. And then we have subtract 2. So this would be our final difference of squares. And you might have been able to see it in the original one. We made that let statement just to simplify things a little for ourselves.